Hello guys, welcome to another video. This is the complete P3 guide for A2 mathematics. So, Pure Mathematics 3 has a total of um, 11 chapters, which are algebra, logarithm and exponential function, trigonometry, differential equation, integration, further algebra, further calculus, vectors, numerical solutions, differential equations, and complex numbers. I have labeled some topics with different colors and divided them into parts. So purple is part one, which is algebra. Um, the magenta is part two, which is vectors, complex numbers, and numerical solution. And finally, green is part three, which is calculus. Now, a lot of students asks that what is the best combination for mathematics in the overall A levels. I say that in AS, okay, in A, you have to understand something that in AS and A2, Pure Math 1 and Pure Math 3 are in their own positions. You can't shuffle them. Okay, for now, one more thing that I'd like to add is for AS, I think people should take Statistics 1 because it is heavily connected to your general maths because there is a lot of topics that correlate to their general maths, which you will remember, and it becomes easy for you to study those. And finally, P3 is blocked in A2. Mechanics 1, I feel like people should take Mechanics 1 in A2 because it's more versatile and also because it gives you more leverage than Statistics 2. And also Mechanics 1 builds up or uses knowledge from your AS physics. So you don't have to waste more time learning something from scratch, whereas you can already use your previous learning and apply it in this subject and easily get past 4 to 5 chapters of M1 out of the 9 chapters that it has. So let's talk more. That is, P3 has a total of 75 marks. Part 1 contains 20 to 25 marks. Part 2 contains 25 marks confirmed. And Part 3 contains 25 to 30 marks. Okay, so how should you use this video? So you should write down my notes and then sit with your question paper. And once you have the question paper, you should open up the in front of your computer. You should open up the mark scheme in one tab. You should have my notes, and you should have a solved video from YouTube or a website in another tab. So if you get stuck, you first refer to the mark scheme and then you solve the question. If the mark scheme confuses you, you come to my notes and see where you have a gap in your concept and then try to solve the question again. Now, if my notes also don't help, which is very unlikely, then you should go to the YouTube video and see where you are making a mistake. Now, all I'm going to say is out of the 75 marks, you should be able to score 62 to 66 marks by yourself. Don't worry, every year around 5 to 8 marks are reserved for student are reserved by CIE. This is to differentiate A-star students from A students and world high students from A-star students. Finally, the of course you guys are going to gonna go to YouTube, right? So my best YouTubers for past paper solved videos plus websites. These are the resources that I used when I was giving my exam. They are Si Xiangeng, she's the number one in my book. Then Zane Matix, then CIE Paper Solved. CIE Paper Solved has a very small library, but that should be fine. So yeah, these are the three ones that I like. You guys can check more, and there's of course countless others, but I feel like these are the best in my opinion. Now, uh, let's slowly get started. Okay, with our chapter one. So, right. So, chapter one is algebra. Right. Now, in algebra, we learn, in A2, we learn two methods. Two methods. Okay, first method is the squaring method, and another method is called the graphical method. All right, now note that graphical method can be used to solve any sum. But do I like this? No. And I'm going to show you guys an alternative technique to this later. Okay. The second technique is okay, so you mainly use it in sums like example x minus 2 less x minus 2 modulus less than 3 minus 2x. Okay, this is the type of sum where you use your graphical method and squaring method. So squaring method, squaring method. Okay, it squaring method can be used for certain types. Okay, example. Okay, the two types are if constant is on one side, example is 9 minus 2x modulus less than 1, or both sides have modulus. Modulus on both sides. Example, x minus 2 less than x. Now, a third method that I like to use is also called the critical method. Critical method. This is used in place for graphical method. All right. So now you guys are not going to understand unless I give you guys an example. So let's take an example math. 1 plus 3x less than modulus of 4x minus 2. Okay, now find the critical values. 1 plus 3x is equals to 4x minus 2, and 1 plus 3x is equals to minus 4x minus 2. You will solve to find that x is equals to 3, and you'll also solve to find that x is equals to 1 by 7. Right. Now, you should draw a line. In this line, you have to write the two values. We got the lowest value was 1 by 7. Another value was 3. Make lines. Okay. Now, in this there are 3 sections. 1, 2, 3. Okay, there are 3 sections. In the first section, in this section, sorry, yes, in this section, you have to use a value less than 7, 1 by 7. So we can use, so we can, let's say we can use 0. Okay, wait. Uh, let's say say x is equals to 0. Then we have to put this value in this equation. So it becomes 1 less than modulus of, 1 less than modulus of minus 2. So it is correct. Now we have to use a value in this section between 3 and 1 by 7. So we can use x is equals to 1. All right, so the value comes as 4 and 2. So this is wrong. Now finally, for this section, we have to use a value that's greater than 3. We can use x is equals to 4. Okay, if we use x is equals to 4, we get 13 less than modulus of 14. Therefore, it's correct. Right. Therefore, when we write our answer, we get x is greater than 3, x is less than 1 by 7. Now, to denotate this, I'll just write use value less than, okay, let's say a is equals to 1 by 7, b is equals to 3. Use value less than a, use value between a and b, and use value greater than b. So this is the critical value method. So our next chapter is chapter 2. That is logarithms and exponential functions. All right. Now, this chapter is very straightforward. The questions that you get are usually 3 to 4 marks, and you are only to use the formulas that I'm going to give you in order to find values in terms of ln or in three significant figures. So let's get started. So the index form y is equals to the power x logarithmetric is x is equals to log ay. Um, log a mn is equals to log am plus log an. Right. Then log a m divided by n is log am minus log an. Uh, log a m to the power n can be written as n log am. Another formula is changing the bases, reversing it actually, is log b, 1 by log b by a. 1 by log b by log ba. 1 by log ba. To have a new base, to introduce a new base, right? Log bc, log ac, log ba. finally, this formula is almost never needed. Log A n m 1 by n log a m. Almost never used. Okay, so these are the formulas that you will be using. Now, the only thing to note that is in A2, we use ln instead of log. Uh, Also, note if you guys didn't know, ln e is equals to 1. Yeah, so that is chapter 2, logarithms and exponential function. Moving on to chapter 3. Chapter 3 is trigonometry. In trigonometry, everything is new because we are introduced to things called double angle formula. However, let's write what we know from our AS and O levels. We know sine square A plus cos square A is equals to 1. Sec square A is equals to 1 plus tan square plus A. And cosec square A is equals to 1 plus cot square A. From from O levels and A's. Now, the new thing that arrived are the double angle formulas. Okay, for sine, we have A plus B sine A cos B plus cos A sine B sine A minus B. Literally the same thing with the signs reversed. Then we have, okay, there's one more one. There's one more. You can also say sine square A is equals to half 1 minus cos 2A. Okay, now the cos formulas. Cos, oh, there's one more sine formula. That is um sine 2A is equals to 2 sine A cos A. Then the cos formulas. Cos A plus B is equals to cos A cos B minus sine A sine B cos A minus B is equals to cos A cos B plus sine A sine B. Then cos 2A is equals to 2 cos square A minus 1. There are three formulas. Okay, so you can write this. It can also be written as 1 minus 2 sine square A and also as cos square A minus sine square A. So these are the three formulas. Very important. Okay. Uh, then we have cos square A can also be written as half 1 plus cos 2A. These formulas are Wait, yeah. These formulas are needed during integration. Okay, moving on. We have the tan formulas. Those are tan A plus B is equals to tan A plus tan B by 1 minus tan A tan B. Then tan A minus B is equals to tan A minus tan B 1 plus 1 plus tan A tan B. And you have tan 2A, which is equals to, sorry, it is equals to 2 tan A by 1 minus tan square A. Now, do you guys want to know something funny? All of these formulas are given in your data booklet. However, you still have to memorize everything and make sure that they're engraved in your bone because you will be dealing with using these, you will deal with complex identity proofs. And let me tell you, A2 identity proofs are no joke. So make sure to write them down at least once every day and memorize them. Okay. Next, we have, all right. Now there is a form. Now, new question type. Question type. Okay. They can say y is equals to a sine theta plus b cos theta. You have to express this in the form. They'll ask you to express in the form r sine theta plus alpha, where r is greater than 0 and alpha is, they'll give you the range as well for alpha, and also tell you if you have to find this in degrees or radians. Now, the formula for finding r is root of a square plus b square, and the formula for finding tan alpha is b by a. Okay, all right, example. All right, another, okay, another method of finding alpha. Okay, no, actually, you just need this. Yeah. Now, okay, so as you see, this is sine. So the one with sine, okay, this is cos. Okay, now if they tell you, if they say sine theta r sine theta plus alpha, so uh the one with the cos is b and the one with the sine is a. All right. Now if I reversed it, now if they said something like another example. for this. Let's say they said r cos theta minus, sorry, not r. Let's say um yeah, n cos theta m sine theta in the form r cos theta plus alpha, then r is equals to m square plus n square, then alpha is equals to b is, okay, b is the one that is not cos, that is not with the cos value. So that is m. And a is the one that is with the cos value. So that's n. So that's that. Okay. Right. Now, they can also say that let's say question type. Okay. Given y is equals to a sine theta plus b cos theta, and you from the previous part you find out that r sine theta plus alpha, okay, plus x plus x. Now, this is amplitude and this is baseline. Now, they can tell you find the maximum value. If they tell you to find the maximum value, you say baseline plus amplitude. If they tell you to find the minimum value, you say baseline minus amplitude. Now, if if it's in the format 1 by r, if it's in the format 1 by r sine theta plus alpha plus x, then then it's reversed. Max value is equals to x minus r, min value is equals to x plus r, literally reversed. Nice. Okay, now I'm sure there's a lot of writing and you guys do not understand. So let me give you a simple example. Okay, okay, example. Actually, I think should I give the example here? I feel like I should give the example here. Okay, let's say example. Let's give a math. 5 sine x minus 3 cos x whole square, which we found out to be 34 sine x minus 0.54 whole square. Now, we can write this as 34 sine square x minus 0.54 plus 0 as there is no baseline. Okay. Now we know that the range of sine x is minus 1 to 1. The range of sine square x is 0 to 1. Okay. Therefore, this can be max 1, min 0. Okay. So as there is no baseline, if the question says to find the maximum value, we have to consider that, okay, we have to consider that 34, uh, okay, so, okay, let's say max. Baseline is 0 plus our amplitude is 34 multiplied by what's the max value of sine square x minus 0.54? The max value of this can be 1 because of our range. So 1, which is equals to 34. Now, minimum value is 0 minus 34, 0, which is equals to 0 because minimum value is 0. Now, what if, sorry, yeah, what if the entire thing was 34 sine x minus 0.54? Then what would be the max value and the min value? So from here, we know that the range of sine x is from -1 to 1. So this max can be 1, min can be -1. Therefore, we can say max is equals to 0 plus 34 times 1, which is 34. Minimum would change because 0 plus 34 minus 1 is minus 34. Hopefully that clears it up. Anyways, you guys don't have to stress it because you guys will understand this once you guys start doing question paper. Okay, now moving on to chapter 4. Chapter 4, that is further algebra. Okay, further algebra. Now, further algebra, we have two things. We have binomial expansion. Okay, we have binomial expansion. General formula. Now, the binomial expansion that we learned have to be, the general formula is 1 plus nx plus n minus, sorry, plus n, n minus 1 2 factorial x squared plus n minus 1 n minus 2 by 3 factorial cube, so on and so on. Now, to give you guys an example, Oh, okay, sorry. Right. So let's move on. The next type is partial fractions. Partial fractions. Now, this is going to be for proper fractions. Okay. For proper fractions, what we do is there are three scenarios. There are three scenarios for proper fractions. That is, let's say, for example, 6 plus 7x divided by, sorry, no, actually, let me give you guys an easy example. Let's say x plus 8 by 2x minus 8, x minus 4. You use the format a divided by 2x minus 8 plus b x minus 4. Then what you guys do is you I'm just showing you guys as an example. Then you move forward, right? X plus 8 is equals to A. Now, if you multiply this here, it becomes A into 2x minus 8, 2x minus 8 cancels out, so x minus 4 plus B, 2x minus 8. Now, you insert a value of x. For example, let x is equals to 4, so A is equals to 0. Find B and vice versa, the other way around. So that's how you do it. The other two methods are if the fraction is in the format 6 plus 7x divided by 2 minus x, 1 plus x squared, which is equals to, you say, a divided by 2 minus x plus bx plus c divided by 1 plus x squared. Now, if it is in the format, um, right, 9x squared plus 4 divided by 2x plus 1, x minus 2 whole square, which is, you say, a divided by 2x plus 1 plus b x minus 2 plus c x minus 2 whole square. And using this method, you solve it. Now, this is partial fraction for proper fractions. Now, partial fraction for improper, sorry, partial fractions, just not say improper fractions. Improper fractions. So, okay, when we have to answer one question. Sorry, before I'll just write down this. So, okay, the example, x cubed minus x minus 2 divided by x minus 2 x squared plus 1 equals to, sorry, yeah, equals to a plus b minus 1 plus cx by d x squared plus 1. So this is a method to do it. Actually, I feel like you guys will feel confused if I write it like this. So I'm actually not going to do it. I'm not going to say this. This is a bad example. This is a bad way to modify this or tell you guys this. So let's answer the question. When is a fraction proper versus improper? Okay, let's say numerator and denominator. Okay, all right. Okay, so so numerator by denominator. So if, let's say, there is a sum where the degree of the numerator, degree, if, okay, this fraction, okay. So this, consider this is numerator denominator. Okay. Fraction is proper if degree of numerator is less than degree of denominator. Then we can use the formulas above. Use formulas above. If degree of numerator is greater or equal to degree of denominator, the fraction is improper. By degree, I mean is example x cubed by 9x to the power 4 plus 1. Sorry, no, actually, no, this is a bad example. Yeah, example x plus 1, x minus 1, x plus 3. So the degree is 1, the degree is 2, because x and x multiplied to become x squared. An example here can be x cubed minus x minus 2 divided by x minus 1, x squared plus 1. So the degree is 3, the degree is also 3. Hence, it is improper. Then, if it's improper, what we do? If the fraction is improper, two methods, two steps. Uh, use long division and find quotient. Then use partial fraction with remainder. So the theorem that, so the thing that we, so what we use, denominator dx, sorry, we call the denominator dx by numerator or equation numerator dx quotient qx and remainder rx. Therefore, we say bx by bx by sorry bx by dx by dx is equals to qx plus rx by dx, and then we partial sorry this fraction is always proper, hence we use the partial fraction formulas above depending on the case to split it further. So guys, that's it for, so guys, Well, also guys, we're gonna move on to part two right now. So part two is with first, we're gonna start with complex numbers. Excuse me. Oops. Where is the orange? There. So complex numbers. Okay. Now, in complex numbers, things are denoted with z is equals to a plus bi. So 1, 2, 3. This is used to detonate complex number. Actually, I think I think it's better to say represent. This is real component of the complex number, and this is the imaginary component of the complex number. Nice. Okay. So for complex numbers, we work with the region b squared minus 4ac less than 0. No real roots. Or to say specifically, or to specify, we work with unreal roots. Okay. We have to learn that my I represent the square root of -1. So example, minus n is equals to root of n times root of -1, which is equals to I root of n. So let's say that z1 is equals to, okay, okay, no, concept. So we move down in concept, let's say for 2. Addition, subtraction, multiplication, division of complex numbers. Right. So let z1 is equals to 2 plus 3i, z2 is equals to 3 minus 4i. So z1 plus z2 is 2 plus 3i plus 3 minus 4i, which is 5 minus I. z1 minus z2, excuse me, z1 minus z2 is equals to 2 plus 3i minus 3 plus 4i, which is equals to 7i, or it's actually minus 1 plus 7i, minus 1 plus 7i. Okay. z1 into z2 is equals to 2 plus 3i, 3 minus 4i, which is equals to 6 minus 8i plus 9i minus 12i square, which is equals to 6 plus I minus 12 is 1. So which is equals to 18 plus I. Now, division. Say Z1 by Z2. Z1 divided by Z2 is equals to 2 plus 3i divided by 3 minus 4i. Now we have to multiply with it, with the denominators, conjugate pair. So, let's note this down. Okay, this is conjugate pair. So what's a conjugate pair? If z is equals to 3 plus 4i, conjugate pair has a star denotated with it, so it's 3 minus 4i. The signs change. Anyways, so this would be like 2 plus 3i, 3 plus 4i by 9 minus 16, which is equals to 6 plus 79 minus 12 by 25, which is minus 6 plus 17i by 25. So you're usually asked to write in the form a plus bi. Therefore, you should write it as minus 6 by 25 plus 17 by 25i. Right. Now, okay. Next is, excuse me, wait. Okay, so concept number 3 is finding factors slash roots of complex numbers. Now, before we move further, you guys should understand something. That is the difference between root and factor. X is equals to 2 is a factor. X minus 2, root. Oh, sorry guys, I made a mistake. That is, x is equals to 2 is a factor, and this is a root. Okay? So remember this. Now, okay. Oh, right. Now let's say, okay, I'm taking a question from question paper. That is, uh 9709 31 October November 20. Okay, I'm taking this question as an example. So, uh, right. Okay. So it says 2x cubed plus x squared plus 6x minus 18 is equals to 0. Given, given that uh given that the first okay, given that first root first root is first root is minus 1 plus root 5i. Okay. Now we can say that second root is minus 1 plus, sorry, minus root, minus 1 minus root 5i, minus 1 minus root 5i. Okay, which is the conjugate pair. Now, the question says find third root. Third root. So it's very simple. Okay, that is we have to use, so we have a quadratic, right? So the quadratic factor is equals to x squared minus sum of root plus product of root. Sorry, I think I made a mistake. Yeah, I was right the first time. This is root. This is factor. Even I forget sometimes. Okay, now, so two things to find. Sum of root and the product of root. So sum of root is equal to minus 1 plus root 5i plus minus 1 minus root 5i. So minus minus cancels this out. Minus 1 minus 1, which is equals to minus 2. And the product of roots is equals to minus 1 plus minus 1 plus root 5i minus 1 minus root 5i, which is equals to 6. Therefore, we can say x squared minus 2 x squared minus 2, excuse me, yeah, x squared minus 2x plus 6, which is equals to x squared plus 2x plus 6. And 2x plus 6. So we still haven't found out the third root yet. Okay, then what we have to do is use long division. Use long division. Square plus 2x plus 6. And let's say that can say that 2x cubed plus x squared plus 6x minus 18 with the coefficient 2x minus 3, 2x cubed plus 4x squared plus 12x minus 3x squared minus 6x minus 18 is 2x squared minus 6x minus 18, which all cancel each other out. Therefore, the third root is 2x minus 3 is the third root. No. Okay. Guys, I'm really sorry. This is 5 a.m. right now. Okay. Root factor. My brain, like I'm actually functioning on coffee, so please forgive me. Anyways, right. Okay. Now, our next concept that I'll be working with, so next concept that I shall be working with is Argand diagram. Okay, so for Argand diagrams. Now for Argand diagrams, let's say actually draw a graph. Nice. Okay, let's draw a graph and let's say z is equals to 3 plus 4i. So this is 1, 2, 3, 1, 2, 3, 4, 4, 3. This is REZ. X-axis is the real component of Z, and Y-axis is the imaginary component of Z. Okay, now this is the point, and this is theta. So the modulus argument system. The modulus argument system. Okay, I have to say Z is equals to modulus of Z cos theta plus I sine theta, where you can find modulus of Z. Modulus of Z is equals to a square plus b square. In this case, it should be 3 square plus 5 square is equals to 5. Okay, and arg Z is equals to tan inverse b by a, where b is the um y is the z value, a is the r's real z value. So you can say that theta is equals to tan inverse 4 by 3, which is equals to 0.927. Okay. Therefore, this example can say 5 cos 0.927 plus I sine 0.927. This is the modulus argument system. Okay. One more note. The modulus argument system has range from minus pi theta to pi. Right. Okay. This is, let's say, okay, let's say this is example 1. Let's say this is 1. Now, for okay, example 2. Example 2, z is equals to minus 3 plus 4i. So the graph will look something like this. Excuse me. The graph will look something like this. Okay. Now this will be theta. This will be alpha for 3. Modulus of z will be once again 5. Alpha will be 0.927. However, theta would be pi minus 0.927, which is 2.21. Therefore, in this case, z will be 5 cos 2.21 plus I sine 2.21. Example 3. Okay, example 3. Z is equals to minus 3 minus 4i. The graph will look something like this. So as both are in the negative quadrant, to look, this is 4, this is minus 3, this is alpha, this is theta. So modulus of z is equals to 5, alpha is equals to 0.927. Now this is minus pi and this is 0. Okay, theta is equals to minus pi plus 0.927. Theta is equals to minus 2.21 rad. Now, there's a certain concept that you have to know in this section. The concept is cos minus theta is equals to cos theta. Sine minus theta is equals to minus sine theta. Hence, we can say cos minus 2.21 is equals to cos 2.21. Sine minus 2.21 is equals to minus sine 2.21. Hence, we can write, therefore, z is equals to 5 cos 2.21 minus I sine 2.21. Okay. Now, final answer or final example. Okay. Okay. Example 4 is 3 minus 4i. So if we draw the graph, this becomes 3, 4 theta. So modulus of z is 5. Theta is equals to 0 minus 0.927, which is equals to minus 0.927. Therefore, we can say z is equals to 5 cos 0.927 minus I sine 0.927. Okay, now this was the modulus argument system. Uh, there is one more thing that I'd like to add. Okay, right. Hmm. Okay. So the exponential format. Now the modulus argument system can also be written in the exponential form. That is, now let's say we have cos theta plus I sine theta. This can be written as E I theta. So if z is equals to modulus z cos theta plus I sine theta, then therefore z is equals to modulus of z e to the power minus I theta. Now let z1 is equals to z1 is equals to uh, modulus of z1 the 1 I theta 1 and z2 is equals to modulus of z2 e to the power minus I e to the power I theta 2. Now if z1 and z2 are multiplied, then this would be z1 z2 I theta plus theta 1 plus theta 2. And for division, z1 by z2, it would be z1 by z2 e to the power minus I theta 1 minus theta 2. Now, let's say now if there ever comes arg u to the power n, and we can simply write it as n times theta. Let's assume arg u to the power 3. That would be 3u. It would be so if u is equals to pi by 7, arg u3 is equals to 3 pi by 7. Very niche example, but you will see this as you guys do question papers. I really can't elaborate further on this. Now, um, okay, this was what? This was concept number 4. Concept number 5. Complex number expansion. Complex number expansion. Now, there are two formulas. Formulas needed are a cube minus b cube, which is a minus b, a square plus ab plus b square, and a cube plus b cube, or a plus b, a square minus ab plus b square. Very niche formula. I only saw this ever in the book. I've never seen this in the question paper. Not a single question paper had a sum like this. Example, this is from your book. Okay. Z minus 5 whole cube 8. Therefore, Z minus 5 whole cube minus 2 to the power 3, because 8 is equals to the power 3 is equals to 0. Now we have to expand it. Z minus 5 minus 2, and let's say that Z minus 5 whole square plus Z, sorry, plus Z minus 5, 2 plus 2 square is equals to 0, which becomes Z minus 7 and Z square minus 87 plus 19 also 0. Z is equals to 7. Z is equals to 87. Oh, sorry. It's not 87, it's just 8. 8 8 plus minus root of minus 12 by 2, which is equals to, take 2 common, 4 plus minus root 3i. That's it. So yeah, one certain side note that I'd like to give you guys is long division and third line rule can also be used, but those take a lot of time and are very long, and there's a lot of chance for you to get the math wrong, so I prefer doing this instead. Okay, next. Um, okay, our next concept is going to be 6. Concept number 6, square root of complex numbers. Now, let's say, example, find square root of minus 2 plus 2 root 3i. So, we can say that square root of minus 2 plus 2 root 3i is equals to x plus yi. Then 2 root 3i is equals to x plus yi whole square, which will lead to x square minus y square plus 2xyi is equals to minus 2 minus 2 root 3i. Now we can compare coefficients. Comparing coefficients. And we can say that x squared minus y squared is equals to minus 2, and 2xy is equals to 2 root 3. So let's cancel out. So x squared minus y squared is equals to minus 2, xy is equals to root 3. And then you can solve simultaneously to find x and y. So yeah, that's another. We're finally left with our final concept of this chapter. All right. The final concept of this chapter is locus of complex numbers. So 7. Oh, this is basically graph sketch. Okay. So uh in A2 we learn 3 different types of locus of complex numbers. First one is first example is arc z minus z1 equals to theta. Hmm. Okay, this can, yeah, all right. Okay, theta, it can be arc z minus z1 greater or less than theta, depending on the question, of course. Now, shape, let's draw shape. So now, for example, let this point be z1. So this is z1. Then we have to draw a line, a half line, and this is theta. We call this z1. And we describe it by saying a half line, sorry, a half line from z1 at an, right, at an angle of theta. That is number one. The second type is drawing circles. Okay, it can be z minus z1 less than greater than r, or z minus z1 equals to r. So, all right, this would be now if, okay, or I'll draw two graphs. Now, if it's this case, okay, oh wait, yes. Let z1 is equals to 0 plus 0i. Then center is 0, right? Then basically, you can just draw a circle like this, right? Since the center is 0, 0. Okay, so this is it. So, these are all radius r, and okay. Now, as you can see, this is a solid line. Okay, the line is solid. Okay, solid line. Now, this is for this scenario only. Sorry, wait. This is for this scenario. So if it says greater or equal to, less than equal to, sorry. If it says greater or equal to, or less than equal to, or equal to, then you draw solid line. But if it just says, but if it just says greater or smaller, then you cannot draw a solid line. Instead, you have to draw. Okay. Instead, what you have to do is, this is, let's say, so this is R, this is R, this is R, and this is R. You have to draw dashed or dotted lines. To draw dotted lines. Okay. Because you have to show that this, because you have to show the locus is within the radius. Right. So boundary is dotted. Nice. So how do we describe this? Describe this by saying uh, a circle with center, a circle with center Z1 and sorry guys, I just checked and to see that a certain part of the video was corrupted. But no worries, I'm just gonna go through the things that went over or that got lost. Anyways, so we were at how to describe this, right? We describe this by saying a circle with center Z1 and radius R. And the third type of question that we get is Z1 minus Z2. It can be less than or greater than or equal to or less than equal to greater than equal to Z minus Z2. Now, guys, don't feel so confused because of all of the symbols. It can mean anything. For example, Z1, Z minus Z1 is greater than Z minus Z2. Okay, so what does this mean? So the graph looks like this. This is Z1, this is Z2. You have to draw, you have to mark the label the 2 points and draw a line, and then you have to draw their perpendicular bisector. So perpendicular bisector, you have to find the midpoint of Z1 and Z2, and then draw a line perpendicular to that line. And you describe it as the perpendicular bisector between Z1 and Z2. Okay, so with this, we covered up complex numbers. There are a total of 7 concepts that we learned here. Okay, now moving on to vectors. Okay, moving on to vectors. Now, to start with, you have to understand that in O levels and in AS, okay, in AS we do not have vectors, but in O levels we had only 2 dimensions, the x-axis, y-axis, and now we're introduced to the z-axis. So if you understand that vector has two key information, magnitude and direction, the position vector is from origin. For example, OA is equals to x, y, z. This is also known as column vector. So let's say AB is a vector ABC. The magnitude of AB is root A square plus B square plus C square. Unit vector is a vector whose magnitude is 1 unit, and I is unit vector due east, J is unit vector due north, and Z is unit vector due wait, excuse me, I think due wait, right, due space. Okay, right. Now we have to also now we have to learn that vector is equals to magnitude multiplied by unit vector. Therefore, unit vector is equals to vector divided by magnitude. All right, let's give an example. Example Let's say vector V is PQR. It can be written as PI plus QJ plus RZ. Sorry, RK. Oh, my bad. I made a mistake. Not Z. This should be K. And RK. Right. So the magnitude of V is root P square plus Q square plus R square. Therefore, unit vector is equals to the direction vector and the magnitude. Okay, so unit vector of V. So we can say root of P square plus Q square plus R square by PQR. That's that. Now, the very first concept. So this is just an intro. Okay, all of this is just an intro. Now we will head on to our very first concept. That is, just like complex numbers, we have to learn addition, subtraction, multiplication, and division of vectors. Okay, so buckle up, kids. It's gonna take some time. Now, example math. Most of the things in vector I will explain with example math because it's better to show rather than tell. Given P is equals to 2i plus, 2i minus j plus k. Q is 5i plus 2j. R is 4i plus j plus k. Now, therefore, write 2p plus 3q minus 4r as column vector. Therefore, you can say 2, 2 minus 1, 3 plus 3, 5 to 0 minus 4 is 4, 1, 1. Where after multiplication and addition and subtraction, we get 3, 0, 2. Right? That's the answer. Okay. Note. Okay. Certain note here that coordinates refer to position vector. And position vector is from origin, right? So let's say A has coordinates 3, 1, 4. Therefore, in column vector, and column vector, we can write it as, should say OA is equals to 3, 1, 4. And in IJK form, we should say it. We can say OA is equals to 3i plus j plus 4k. Okay. Now, let's say there is a vector Okay. Let's say we're given a graph, right? We're given a graph and uh this is OA and this is OB and this is AB. So if they ask us find AB, how do we do it? We know AB is equals to AO plus OB. Or okay, this is how this is how I prefer. However, you can also do it like this directly. You can say uh you can say OB is equals to uh sorry, you can say OB is equals to OA plus AB, AB is equals to OB minus OA. By the way, just so you know, if you use AO, your A if OA is 314, AO becomes minus 3 minus 1 minus 4. So you gotta keep that in mind. Okay. Now, moving to concept number 2, that is collinear slash parallel lines in a vector of vector. Right. So if AB and BC are parallel, then AB by BC is equals to K. There will be a constant. Example, AB is equals to PQR. BC is equals to MNO. If AB and BC if are collinear, then okay, I should add something. Parallel slash collinear. Oh, actually, if AB and BC are parallel, okay. No, I think I forgot to mention something. If AB and BC, they can't be parallel, they can be collinear. Excuse me. Sorry guys. Nothing's wrong. I just forgot to mention something. Just move this right here for 1 sec. Okay, just a second. So we said if AB and BC are collinear meaning. So what is collinear? If you guys don't know, collinear is A, B, C, a point in the same line. Okay. Also, if AB and CD are parallel, then AB by CD is equals to K, where this is AB and this is CD. Right. Okay. Now we can just We'll copy back the example math. All right. Example for collinear. Now, if AB and BC are collinear, then we can say P by M is equals to Q by N is equals to R by O, which is equals to K. Therefore, if AB and CD are parallel, then we can say write AB parallel to CD gives us AB by CD is equals to K. Oh wait, why am I repeating? I already wrote this, right? Parallel than this. Right. So, um, example. Collinear. Just write. Okay. Example for parallel. Okay. So we can say AB is PQR and CD is MNO. Then if AB is parallel to CD, then P by M is equals to Q by N is equals to R by O, which is equals to K. Right. Now let's add a certain note. Note. Okay. Actually, no notes. I think this is all I want to say. Right. Now, concept number 3, finding fractions of length of a line. Okay. Finding fractions of length of a line. For example, let's say if a line A, B, C says 3, 5. Okay. This means AB by BC is equals to 3 by 5. Okay. All right. AB by BC is 3 by 5. Therefore, we can say AB by AC is equals to 3 by 8, or BC by AC is equals to 5 by 8. Nice. That's how you find fraction of length of a line. What's next? Dot product of vectors. Did we go? Right, I think we went a long way. Wait. All right. From here, let's start. Dot product of vectors. So what is the dot product of vectors? So we know that I is unit vector due x direction. J is unit vector due y direction. And k. K is unit vector due z direction. Now, if there is an angle, so this is A, this is B, and this is theta, we can say A, B, A, B cos theta. So vector A multiplied by vector B is equals to magnitude of A multiplied by magnitude of V cos theta. This is the general formula. Going outwards. General formula. Okay. All right. Now, example math. Example. A is M and O. B is RST. Then AB is MI plus NJ plus PK into RI plus SJ plus TK. Right. If vector A and vector B has an angle theta included, then we can represent it as uh, then okay, then representation becomes, watch, M N O RST. RST is equals to M square plus N square plus O square multiplied by R square plus S square plus T square cos theta. Nice. Next concept, concept number 5. That is line equation of vector. Line equation of vector. Okay, so the general formula is final position is equals to, so remember, final position plus initial position is equals to initial position plus direction, which is also called sometimes as displacement vector. Okay. What you can do from, okay, so to represent, we can just draw a graph. Okay, where, oops. All right. So this is OA, this is OB, AB, and this is the line. Okay. Direction vector is very important. This is the direction vector or the displacement vector. Okay, so let's say in order to find OB, in order to find OB. Okay, no, actually, let's say there is a point in this line. There's a point in this, sorry. Okay, let's say there is a point in this line. The point is N. So they'll usually ask us to find what is the position vector of N. So we can say ON is equals to OA plus lambda into direction vector. So which is therefore ON is equals to OA plus lambda AB. Right. We can represent this as R is equals to A plus TB. This is the representation of the vector equation line. Okay, where this is the point in line to be found, initial position, constant, direction slash displacement vector. Right. Okay. Now, uh, there's another way we can represent this. Okay. Okay, let's say A is equals to LMM and B is equals to PRS. Okay, therefore we can say R is equals to LMM plus T PRS. So we can say X, Y, Z equals to L plus PT M plus RT N plus ST. Okay, which, right? Now these are your singular equations that you can later on use. My bad. Nice. Okay. Uh, Parametric equations. Okay. So next concept is concept number 6. Intersection of vectors. Intersection of vectors. All right. Okay. So the intersection of vectors is, I think, the biggest concept that involves the vector equation line and also the dot product of vectors. So let's get started. Okay, so in 2D vectors, two cases. That is, they can be parallel. Number one is parallel, say AB, CD, or they can intersect. However, we are not working with 2D vectors. We're working with 3D vectors in space. So in 3D space, two vectors can, okay, they can be parallel if they are not parallel. They will intersect at some point. They are skew. Okay, right. Now what's the difference? Very simple. When intersecting, let's say there are two lines. Okay, so this is L1, this is L2. This is X1, Y1, Z1, X2, Y2, Z2. Okay, right. So if they're intersecting, we can say X1 will be is equals to X2, Y1 is equals to Y2, and Z1 is equals to Z2. When skew, 2 points are equal. 1 point is different. Okay, let's work with an example map. Right. Example. This is taken from your book, exercise 9E, question 1. Given x is equals to 3 lambda plus 4, y is equals to 5 lambda plus 1, z is equals to 4 lambda minus 3. And x1, y1, z1. x2 is equals to mu plus 1, y2 is equals to mu plus 4, and y3 is equals to 2 mu plus 5. Now we can say x is equals to x, 3 lambda plus 4 is equals to mu plus 1, mu is equals to 3 lambda plus 3. We can say x1 is equals to x2, y1 is equals to y2. Therefore, we can say 5 lambda plus 1 is equals to mu plus 4. Mu is equals to 5 lambda minus 3. Therefore, mu is equals to mu, right? We can say 3 lambda plus 3 is equals to 5 lambda minus 3. 6 is equals to 8 lambda. Sorry, 6 is equals to 2 lambda. 6 is equals to 2 lambda. Lambda is equals to 3. If we found lambda, we can also find mu. And say mu is equals to 9 plus 12. 9 plus 3, which is equals to 12. So mu is equals to 12. Right. Then we should make a table. Make a table. A nice table. This is the best way to represent this type of question. So nice. Okay, so you can say this is x, L of x, L of y, L of z. Lambda is equals to 3 and mu is equals to 12. Now, what we do is we insert the lambda values. We insert the lambda values in this equation and the mu values in these equations. Okay, sorry. All right. So to make better representation, I think I should just gonna highlight this and this. Okay, so the value of this is 13, this is 16, this is 9, this is 13, this is 16, and this is 29. Okay, therefore the answer is lines are skew. Nice. Okay, so uh, one more thing to note, I think, that is, all right, mm, number, this is what? This was number 6, right? This was number 6. Number 7. What is the angle between two straight line or tangents? Okay, the formula is tan alpha is equals to m1 minus m2 by 1 plus m1 m2. m1 is equals to gradient of lines. m1 large, m2 small. So yeah, that is that. Now finally, an extra note. Okay, extra note. So guys, when you are trying to find, let's say this is L1, this is L2, and this is theta. So when you guys are trying to find the angle, you have to make sure that this is going outwards. Okay, let's say this is O, this is A, this is B. So your formula should be like, make sure the lines are going outwards from the angle. So your formula should be OA into OB is equals to OA OB cos theta. Now, again, similarly, if it was something like, be like, if it was something like, let's say, P A B theta, then it should be PA uh, PB is equals to PA PB cos theta. So yeah, this is everything that you need to know for vectors. We have less than a minute. think I am going to take this section and put it here near this. Right. So we're done for this part. Okay. Good. Okay, guys, we have one more topic for part two. That is, wait, that is chapter 7, which is numerical solutions. Now, the thing about numerical solutions is that what I'm going to do is, okay, uh, numerical solutions is a chapter that I'm completely going to explain to you guys using example math because there is no written theory that I can give you guys. Like in vector, there was some written theory, and I used a lot of example math. In numerical solutions, I'm mostly going to be explaining using example math. Okay, so let's go. But yes, I will give you guys an overview. So, overview is you'll be given an equation. You have to distinguish two functions. You may be asked to prove an equation or draw graphs, find number of roots uh, from graph, then okay, you have to find fx. Okay, uh, you will be given uh, you will be given and or you'll be asked to find an equation f. Okay, no, wait, I should say for fx f if fa if fa and fb have opposite signs, then root is present between them. Okay, so we can say therefore b alpha a. Okay, guys. All right. And finally, you have to use iterative formula. This is the new thing. Iterative formula to find the value of alpha. Starting value may or may not be given. Okay. The only skill you will need in this topic is drawing graphs. So, without further ado, let's get started. I'm going to take the example maths from your book. I'll mention I'll give you guys the exercise number and the sum number so that you guys can follow along. So the first math is exercise 6A number 1. So for 1A, you have to draw a graph. So we have to draw the graph of y square. So y is equals to x square, and sorry, this is a bad line. Let's say this is 1. So y is equals to root of x plus 1. Okay, 1b, this is 1a. Okay, 1b, the answer is 2 roots. Why? Because there is 1, 2. Because 2 points of intersection. Right. On C is y is equals to root of x plus 1, y is equals to x square. So root of x plus 1 is equals to x square. X square minus root of x plus 1 is equals to 0. Therefore, we can say fx is equals to x square minus root of x plus 1, x plus 1. Right. Okay. Now, for f minus 1, the value is 1. And for f0, the value, sorry, for, yeah, the value is minus 1. Therefore, sign change shows root lies between f minus 1 and f0. Okay. Now, another example math, but this time with iterative formula. Okay. Okay. Example math. Exercise 6b, number 7. So for 7a, it's x to the power 4 minus 1 minus x is equals to 0. The power 4 is equals to x plus 1. X is equals to root 4 x plus 1 shown. Okay, 7b. X n plus 1 is equals to 4 x n plus n, sorry, xn plus 1. Okay, now that's the iterative formula's equation. Now we have to find the value of x. For, okay, let's make a table. For xn and xn plus 1 is equals to 4 root of xn plus 1. Right. So the starting value, we can say x is equals to 1, x1 is equals to 1.5. Okay. Um, because it's given, right? X1 is 1.5. All right. So when x1 is 1.5, this is 1.2574. When x2 is 1.2574, it's 1.22576. When x3 is equals to 1.22576, it is 1.22143. X4 is equals to 0.22143, it is 1.2208. And x5 is equals to 0.2208, it is 1.22076. X6 is equals to 1.22076. The value is 1.220744. Sorry, 075. Now, we usually get our answers from x is equals to 5 to x is equals to 8. 1.22075, 0.220744, and finally x8 is equals to 1.220744, 220,744. And x9 is equals to 1.220744. The value is the same. Right. Now, do we individually? So how did we do it? So did we, let's say, okay, now instead of just making this table and making it very lengthy, already have this done. Okay, I want to copy this down, and now I'll explain how I did this. Okay, so instead of making a table, we can just write as it is. Now, you could just say x1 is 1.5, x2 is 1.2574, x3 is 1.2258, x4 is 1.2214, x5 is 1.2208, x6 is 1.22076, x7 is 1.22074, x8 is 1.22074, and x9 is also 1.2207444. Usually, we start getting ans from x6 to x9. Now, now, again, I know what you guys are doing. You guys are thinking that you have to take this value, then you have to put it here, and then you have to take this value and then put it back here. No, that's wrong. Okay? There's a much simpler way to do it. So, calculator technique. Calculator technique for iterative formula. Calculator technique for iterative formula. So what you do is, first, open calculator and type your starting, okay, value, which is x1. That is, in this case, x1 is equals to 1.5. Okay. Press the equal sign. Then write down the iterative formula. Write down the and put ants in position of x. In this case, in this case, our IF was x n plus 1. X n plus 1 is equals to root 4 xn plus 1. Now, this is now in the calculator. In the calculator, you should write uh, root of 4 ants plus 1. Then this is what you should write in the calculator. Okay? All right, this is the calculator. Then again, press equal to sign, and that's sorry, and the next value you get is x2. Press equals to again, and that's x3. Repeat until you get your required value. Okay, guys, that's it for iterative formula. I think it was very big, actually. I think I can make it kind of smaller. All right, just right. All right, okay, nice. That's a wrap for iterative formula.